So today, our first tutorial on advanced social psychology and judgment and decision making. I'm Kit. This tutorial will be on registered replication report assessment. So first, we'll talk about a bit of housekeeping matters, and then we will provide an overview on the registered replication report assessment task. So let us introduce ourselves. The leading today is myself, Kit. I'm an MPhil student supervised by 3D, particularly interested in judgment and decision making in health, medical, and environmental settings. The supporting tutor today is Tracy Chow. She is a teaching assistant at the psychology department. As mentioned, our tutorials will have at least 5 sessions. This session focuses on our assessment. So this is session 1. And we may have the session 6. Depending on your leads, it will be an open style session. So please feel free to contest and answer questions on Slack. Why is this important? It is because others can answer and learn from our answers or discussions. We may not know the full answers to your questions, so it's kind of a discussion. Emails are reserved mainly for personal matters. This means issues only related to you. For example, you have complaints about your grade, or you have complaints about your free riding group mates, or you need to submit medical proofs that you're sick. Hopefully you won't, obviously, just in case. So the Slack links are on Moodle and also here. So I think you have joined the Slack already, but you haven't, please click on those and join those links. So our tutorials are online, recorded, and will be shared with the world through Twitter and Open Science Framework. Each session 2 hours. We have 5 sessions of this. So tutors will take turns to demonstrate and to support. Each session has a demonstrating tutor and a supporting tutor. Ideally, please attend the sessions you register for. We understand you may not be available on some days or some hours, or you may be sick on one day. So do feel free to join the other tutorial. Tutorials are optional, which means we will not take attendance. However, it's very important and helpful for you to join our tutorials. If you want to do well in our courses, or maybe you perhaps publish a manuscript, our tutorials will be very helpful for you. So what is our assessment? It's a team project with a group of 4. The goal is to compare and evaluate the original article, pre-registration of the RRL, and the registered replication report. So there are 3 deadlines. Remember, these 3 deadlines. First, substantive 27. You should submit the draft of the RR assessment. So it's a Sunday, 2-3-5 which means at night. And then the next week, please submit the peer review of the RR assessment. Then based on the peer review, please submit the final version of the RR assessment on October 11th. The grading will be only based on the final version. However, not submitting the draft is not allowed, so please do submit your draft. It's also important to improve based on the peer reviews received on your draft. So to work on the RR assessment, you will need to go through these 3 to 4 major items. First, the pre-registration of the original article, if it's available. However, very often, the registration of the original account was not available. particularly in the older articles, like pre-registration in psychology particularly has a relatively shorter history. So many of the older catalysts were not pre-registered. So, and then this is followed by the original article. You have to read the original article, pre-registration of the registered report of the RRL, and eventually the final report of the RRL. So what is the importance of the RRL? As 3D has mentioned in the lecture, there's a replication crisis across different fields. Around 20 to 70% replication success across different fields of psychology and different mass replication projects. It's very important to revisit the classic findings, particularly in social psychology, judgment and decision making, before we actually work on low-flow studies that are built on the classics. Also, before we actually apply those classic findings to real life, we need to revisit them to check if they're reliable. So through pre-registration and registered report, we will have a clear plan, power analysis with the minimum sample size required to detect the effect. The goals are to reduce questionable research practices and researcher degrees of freedom. So there are two types: pre-registration. This means registering a study or a series of data with a time-stamped record. And pre-registered report consists of two stages. Stage 1, introduction, method, simulated results. This means results that are log real based on simulated data. Followed by peer review and the stage 2, real results and discussion. So some manuscripts you assess use pre-registration format and some use registered report format. So why registration? As you can see from the plot here, from Allen and Mella, the percentage of low findings in registered report is much higher comparing to the traditional literature, which is around 10 here. Very often in the traditional literature, significant findings are way more likely to be published, but they may not be reflective of the reality. They may not be reliable. In reality, a registered report more likely to result in low findings, which are actually more realistic and reliable. So there are 4 major components of the RR assessment. First, abstract, main body, coding, comparing the replication pre-registration to the final manuscript, and comparing the original article to replication. From the main body onwards, there are a checklist that you need to go through and elaborate. We'll describe each of these items in this tutorial. We'll do so with examples from last year's students' projects. Yes, and now we'll have a template. So when you are free, please click on the template and make great use of the template. And we have lots of examples, 11 examples from last year. Here now, I'm going to demonstrate using an example from last year to show how is it like the work structure. So first is a demonstration for the structure and the key elements you need to include. I'll provide a brief summary, very brief summary, and I'll elaborate and discuss more about the details of each element in later slides. First, very simple. Please provide your links with both your personal and university emails. The reason why you need to include your personal email is that you will very likely graduate from this university. And sometimes it may not be possible, we may not be able to contact you. So please do provide your personal emails so that we are able to contact you when we have ongoing projects, when we try to submit your work to a journal. This is quite important. And if you have not done so, please register OSF Open Science Framework and ResearchGate's profile account. These are important elements for open science, for sharing your work. And please provide important information links, the OSF ResearchGate links. Please make sure this is accessible when you're logged in the links, emails and IDs, your student IDs. So please select the contributions of each student in your full group, your group. So free writing is not allowed, so there should be roughly equal contribution of each student. Please to provide the citation of the original target article and the RR with links. Here, the students included the citation of the target research article, but they did not include the citation of the RR. So please remember to do so. Please also provide links for the OSF links for the data code and the pre-registration of the RR. This is an abstract, a brief description of the target original article and the RR in terms of effects and results and the goals of the RR assessment. And this is followed by an introduction of the description of the original article, the methodology with tables. Here you can see the tables here. We prefer tables over long tests, so if it's possible, please use tables. A test is necessary, but tables would be great, and figures. So you need to describe the phenomenon in terms of the relationship between dependent variable and dependent variables. Again, please report the results ideally with tables. And please discuss the importance of replicating the original article. This may include academic, theoretical, public, and societal impact, called cost-benefit analysis, etc. We will visit this later. Please describe the possible reasons that the original article might replicate. Some of the reasons, possible reasons may include transparency, open science practices, and why wouldn't it replicate? Please describe the possible factors why the original article might not replicate. This may be due to lack of transparency and lack of reproducibility. And this part is quite important. You have to do these things. First, assess the quality of one, the original article. Second, the RR pre-registration. Third, the RR final report or manuscripts. Last year, students assessed based on the clarity, whether reporting of method and results are clear, transparency, whether the method analysis results files are transparent, reproducible, and whether the article provides sufficient information for us, the data and code, particularly for us to repeat the step, reproduce the results, check we can find same results, and make method record the design, whether it's well designed, if there's any deviation from the original study, this may be in terms of experimental control, sample size, and statistical power. This year, please also provide quality assessment on whether this design is suitable for testing hypothesis, and please do calculate statistical power and conduct power analysis. We will discuss more about power analysis in the coming tutorial next week. We will go through courses assessment of the original article, RR pre-registration, our manuscripts in more detail with other samples in this tutorial. As you can see, first, quality of the target original article, quality of the RR pre-registration or register report, stage 1, and third, quality of the RR manuscripts. So please also describe how your group assessed the original article, pre-registration, and RR. What files did you download? What files did you have to access? And what criteria you use to evaluate, to assess? There are quite a lot of criteria, and we go through these criteria later. Please describe the results of the original and the RR. Please try to report the or calculate the effect size. Sometimes the effect size may not be available in the original articles of the CIs, the confidence intervals, the p-values. The p-values are very often available, but effect size and confidence intervals may not be available in the original article. We will discuss a bit more on this later in this tutorial and the tutorial 2, the effect size and confidence intervals. And here are some plots, which is good. Please describe how the RR contributes to the field and the understanding of the phenomenon. Please discuss the key takeaways, things learned, which may be useful and transferable for your replication project or maybe future projects as well. Coding, this part is important. You need to check whether the data is available, accessible, downloadable, and understandable. This is followed by checking whether the data and results is reproducible. This means that can you rerun the analysis based on the data code scripts provided and find the same results? Can you repeat the step? Here the students try this on OWL. Please check for errors, including insufficient information error, minor numerical error, major numerical error, and decision error. See tutorials like tutorials like I will go through this later in later slides. Then you work on the pre-registration assessment. Several things. Check if the hypothesis, inclusion and exclusion criteria, power analysis are available. And then you state, copy and paste assess the hypothesis, the inclusion and exclusion, right? You also discuss the power analysis, data collection, assess, data analysis in terms of rigor, clarity, and specificity. And here you can see a table here. It's nice to have some tables. Here you compare the pre-registration to the final report of the manuscripts, the pre-registration planning, and deviation documentation. We'll go through this in more detail later. And then you compare the original article to the replication and hypothesis, sample, population, method, and results. You may compare the original article with the replication with reference to Brandt's et al. Replication recipe. This is the table of data based on that. So the similarity and differences in different aspects. You may classify the replication with Lebet et al. 2018. Most of our replications are very close replications. I'll go through this in more detail later. And then you may evaluate the outcome of the results, Lebet et al. 2019, in terms of signal consistency, direction, Matthew. By comparing the replications CIs with the original effect size. I will go through this in more detail later, and this part is important to ensure that your reference is correct, indent, APA style with a DOI link. You can find the DOI link with cost graph. And journal name should be italic here. So here this should be italic. I'll go through most of these elements in more detail in this tutorial. So first, we'll talk about the introduction. We describe the effects in terms of the method, the relationship between independent variable and dependent variables, and results, and related concepts of theories. And then we describe why was it important to replicate. This may include reasons such as lack or zero direct replication, theoretical, practical, both theoretical and practical importance, cost-benefit decision analysis. The goal is to enhance efficiency and reliability of science. In some cases, there might be mixed findings, controversial findings, controversies in different directions. Sometimes a method analysis, which is quantitative synthesis of multiple studies related to the phenomenon that summarize the literature, might be published. If a meta-analysis suggests serious publication bias or a weak effect, it's quite necessary to replicate. Then you follow by a discussion on why would it replicate. This may include reasons such as a published meta-analysis that shows limited indication of publication bias and shows a substantial effect, as well as open science practices, which is often not the case in most original articles. High statistical power. We go through this later in moment, and effect sizes. Why wouldn't it replicate? This may be due to reasons such as lack of transparency or reproducibility. Sometimes the field values just fall below 0.05 and something like 0.05, 0.4. Another possible is in small samples. There may be mixed findings with the follow-up studies or conceptual replications. And in some cases, there are statistical errors that you can try to check for. So let's use an example to demonstrate. This is an example from a previous student. This is on the main body intro. What is the effect? What is the phenomenon? The student described the effect, phenomenon, on the relationship between the independent variable and the dependent variables. Here, on the causal link between subjective commitment in a relationship and the called forgiveness process after being betrayed through an experimental study by measuring the activities of participants' reactions to hypothetical betrayals in their relationship. I think they describe it fine. Then they talk about the method. Undergraduate students involved in dated relationships for at least 1 month. And they mentioned that the participants were divided into 2 groups, which is fine here. The student mentioned the 4 measurements here. Tendency to exceed, voice, loyalty, and neglect. So the student described the phenomenon and the method quite clearly. And this is a table by the students. It's good to include tables as mentioned. We prefer some tables over tests in some scenarios. They describe a bit of information about primary research related concepts. And here they have a section on the measurement. So for measures, I think it's better to use our templates. We will provide you with templates, more instructions on templates, how to use them later. I think we need to be clear on how we measure things and what are the conditions of the experiment. Like, for example, how many conditions? 2 or 3 conditions. Is there a control condition? That's sort of key issues to enhance clarity, so that the readers are able to understand the design. This is the link for our template. You will click on this. We'll talk more about this later. Now, the students discuss the results of the original article. And the results of the replication. This is fine. So the original article find a result that supported the hypothesis, but the replication found no effect. This is what the student said. I think the term no effect is a bit too absolute. Even an effect, like let's say correlation 0.01, it's still an effect, but a tiny one, a very tiny one. It's important to recognize that no findings do not imply no effect. It's better to say the replication failed to find support for the hypothesis instead of saying there's no effect. Then they discuss why was it important to replicate. They consider factors such as expected utility, cost-benefit analysis, which is justified and reasonable. However, it's better to mention more about the benefits, such as testing if that is reliable and consistent, before working on further local research that builds on these classic findings. And then they mentioned the academic impact with reference to Google Scholar citations, which is fine. They also mentioned the practical impact in social work education. Here, educational purposes, social workers, teaching materials for social workers. It's better to provide some key references when you make claims like this related to the literature. The students didn't provide any reference to this particular part. The students also mentioned methodological concern of the original article. So the original article did not report effect size. They did not have a power analysis. This is very important for reproducible science and for reliable science. The original article simply reported females. These are very great points raised by the students. And the students mentioned the hypothesis is supported by academic literature. This is good, but a bit fake. So it would be great to elaborate what specific articles with some examples, some key references. Most ideally, check if there are successful conceptual replications or follow-up studies or meta-analysis that support the idea that the article might replicate successfully. In some cases, they may not be published in meta-analysis or review papers, but do try to find them. And very often there are at least some conceptual replications or follow-up studies that is related to the phenomenon. The students also mentioned that the significance of the effect is supported by p-values. As mentioned, a substantial of classic findings have significant p-values, but a substantial proportion of these classic findings failed to replicate. Like around 30 to 60% of psychology findings fail to replicate. It's better not to rely on p-value. P-values below a certain mark is not a good reason on why the study would replicate. We will talk more about p-values in the coming tutorials. And the students calculated the effect size of the original article, great effort there, but they did not mention the effect size measure, the unit. Is this code handy? 1.33. I think this is code handy, but students should report the unit of the effect size. Otherwise, it may be confusing. The students also mentioned that many important statistics are absent in the original article. Right, in the standard error, confidence, credibility of the measurement, reliability. These are great points raised by students. The lack of sample size and not the concern. Small sample size. And then the second part, the main part, what are the quality indicators? What are the ways we can assess? This is for 3 parts. The first, the original article. Second, the pre-registration of the RL. Third, the final report of the RL. Very key, transparency, open science, reproducibility, method recall, whether the design is suitable for testing the hypothesis, and power analysis, statistical power calculation, which we'll work on in the next tutorial. Now we look at an example of quality assessment. First, the target original article. The students mentioned the reporting in exclusion criteria and results is ambiguous, which is often a problem in many older articles. It's also very great effort by the students to check if the number of participants is consistent with the degree of freedom. Here, you can see number of participants 92, degrees of freedom 89. So there's a mismatch here. It's an independent design, so that should be is 92 minus 89 equals 3, so it doesn't make sense. It was possible there was unreported exclusion of a participant, which is often a problem in some older articles. So it's great that the students check this. The students also mentioned the data and code are not available. Another problem in many original articles. The students also mentioned the problem of reproducibility. What does it mean by reproducibility? So since the data is not available, the code is not available, it's not possible to reproduce what the original researcher exactly did. By reproducing, we mean we do the analysis over again using the code, the data, and see if we can get the same results. And this is a great point. And then they mentioned issues related to method recall and design quality. Loadability, the conclusion of control condition to eliminate the confound. I think the word eliminate is too strong. To reduce will be better. The students also mentioned the problem of limited statistical power, low power. They mentioned the effect size was unreasonably large. 0.82, the coherence of 0.82 is not unreasonable. It's possible. It's important to recognize that effect size, whether it depends on context. There's no absolute criteria to watch whether an effect size is reasonable or unreasonable. There's some heuristics, there's some benchmarks, but they are not absolute. It's important to recognize these benchmarks. For example, 0.2 small, 0.5 is medium, 0.8 is large. Context dependent relative. We will go through more about these benchmarks, the effect size benchmarks or descriptors in the coming tutorial. As students discuss the pre-registration of the RL, the student needs the file names of the project, including data file, experimental, experimental file. These are great open science practices by the RL pre-registration. They also mentioned that video recorder tutorial are provided. These are great practices. This is for which wishes to follow steps to analyze the data. However, there's a major problem, which students caught it. Great job there. The students mentioned the reproducibility is low. The researcher did well in other steps, but there was some problem with the dominant data sets are not found. This means that in doing reproducibility work, every step is important. A single step can lead to barriers in reproducing the results. In this case, the domain status set was not found, so the students were not able to reproduce the results. The students also mentioned there was a clear prerequisite plan for the method session, a comprehensible protocol for experimental procedures in OSF. This is a great practices. The students mentioned the experiment materials and the user guidance were uploaded for the collaborating laboratory. So in this case, there are many labs, so it's good that the materials and user guidance for that. However, the user guidance only provided very brief info. So it may affect the project's quality in terms of adherence. This is a reasonable point. They also mentioned another possible limitation, the lack of the control condition, which was present in the original study. This is a reasonable point raised by the student. The students also mentioned the power analysis is not provided. The students also mentioned 2,000 domain variables, which is much larger than sample size of 80. Be careful with this. Domain variables means 0 or 1 to indicate the absence or presence of some categorical thing, such as 1 if you're married, 0 if not married. This is different from sample size. Sample size is related to power analysis, but number of domain variables is not quite relevant here. So we'll discuss more about power analysis and how to calculate statistical power and number of participants required to get a certain effect in the later tutorials. And the students evaluated the RR manuscripts. So a good manuscript should provide locations to OSF links. So students mentioned easily located online resources. We point there. The students mentioned the level of transparency. The RR provide full experimental materials, full data set with results in OSF. However, the students mentioned they were not able to reproduce the result due to 2 reasons. One instruction in the guideline and the different results as the reported one. So there were some problems. Even though the researchers were very transparent in most steps, 1 or 2 problems may lead to barriers in reproducing the original result. It's also great that the manuscript provide here and comparison methodology on how the leading laboratory and collaborating laboratory standardizing the experimental procedures, pre-recorded instructional videos were provided to instruct participants. This is a good practices because the participants need to do the study. They need to be clear. They need to clearly understand the instructions. This is a good practice. The students also mentioned that the original author was contacted to enhance accuracy in materials and procedures. This is what we will do in our replication extension. We will contact. We actually have, in fact, the contact emails the original authors, and we'll get back from them later. We should mention that the final report design is same as the pre-registered design, which is good. Follow the research design. Consistency. High statistical power. Yeah, this is a reasonable point. This is a good important elements of a good power. This is followed by the main body, the checklist. Did it replicate? How do you know? We'll go through the BioLL 2019 guidance in later slides. Another point is, if the results differ, which of the two do you find more convincing? Which of the two means the original article or the RRs? Most of the students last year did not include this part. It would be good to include this process. Well, In most cases, due to most open scientific practices and high statistical power, the RLs are more convincing. The students should also discuss areas of improvement with constructive recommendations. The possible improvement. This may include enhancement of reproducibility, being careful with the materials and the code to share, being key with that, increased transparency, multi-lab collaborations, multicultural collaborations, such as psychological science accelerator, as well as many labs in the past few years, different countries, different labs involved. Then students can discuss the lessons they learned from your own replication. This may include importance of pre-registration, reproducibility, need to be careful with every single step, and the importance of verification of the steps. This is an example for the recommendation of improvement. In this case, our participants were all students. Students mentioned recruiting participants of different age groups, different level of education, different socio-economic status. But this is reasonable. The students also mentioned conclusions should be based on well-recognized standards or criteria. It's a good point here. We will have lots of criterions. And then the students also mentioned that quality of the original ideas should be analyzed comprehensively in terms of different aspects, different methods. Good point then. Students also discuss what they learned. It's less likely for the researcher to fake data or mislead people with open scientific practice. Good point, but a bit too generic. It would be better to mention possible transferable knowledge and skill to their own replication projects, or maybe other projects, or maybe their phases in the future. So let's now take a break, 5 minutes break. So the break is over. Now we'll talk about coding. So coding includes 3 parts: pre-registration coding protocol, specifically whether the data is available, can be accessed, can be downloaded completely with reference to Obel's et al. 2019 analysis of open data and computational reproducibility registered reports in psychology. So that includes a coding book, which we adapted based on that. So welcome et al. 2018, ensuring the quality and specificity of pre-registration. And then we work on reproducibility check based on Hartwig et al. Error classification scheme, which includes insufficient information error, minor numerical error, major numerical error, addition error. Then you need to work on pre-registration assessment on hypothesis, inclusion exclusion criteria, power analysis, data collection, design, and data analysis. So first, does the article states a lot the data available? So yes available can be as simple as a URL link or data file, or sometimes a more concrete statement. So please check for several sessions. Supplementary materials may consist that link for data file. Acknowledgements, sometimes it's their appendix, and sometimes the link may be in the results. And then you check how are the data accessible. Is it via URL or you need to request from the authors? And if the data is not available or is not provided, you need to both state the reasons or why was not provided. This may be due to legal, ethical, or practical reasons. And sometimes the article did not indicate a reason. So if the data is available, you don't need to code the third item, which is this sentence. If the data is not available, what reasons are provided? So what does the link lead to? This can be a web page, supplementary information, OSF, repository, and you need to check the file format. Maybe CSV, XLX, SAV, etc. So make sure you download the files, and you have to access. First, you have to have the software at the first place, like SPSS data, OW, etc. And sometimes it may be a zip file that you have to download first, and the zip file consists of the different data files in different moments. So does all the data needed for evaluation production of the research appear to be available after brief review? You need to check this. Sometimes only some of the data is available. Sometimes all of them are available. Sometimes it's not clear. You don't know for sure actually. And then can you understand the data? This is important. Please check for additional documentation. Like, is that a code book or data dictionary? Do you understand the labels? Do you understand the column labels? And then, are the analysis scripts code available for download analysis? Make sure you have the software first. maybe RStudio, maybe GenMovie, maybe SPSS. If you don't have those, please download those first, and then download those software first and download the files. And data use license. There's several types. CC0 means is for public domain dedication, which means that allowing the copyright owners to utilize the work without restriction. So no restriction, you can use it. You have that. And CC0 means it's a general permissive license. It requires attribution. And sometimes some articles do not include any sort of license. So to repeat, CC stands for Creative Commons. So please be aware of the label, of the symbol of CC, which I will demonstrate with an example. So here, we will try to code these two links, the article link and the OSF link, with the checklist we just showed. And I will demonstrate this. This is relatively simple. As you can see, this is the link of the article, the our registered replication. So the first question is, the first item in the checklist is, are the data available? Very simple. And we have to check through this. It's not easy to find. But here is in the result section here. Under the plots, and see, you can see a link here. You click on this, and you'll find the data. So data are available. So how are the data accessible? File via URL, simple link, OSF link. And what does the link lead to? OSF, Open Science Framework. And this key question: what is the file format? So click on the OSF link. What's the file format for the data? And here is data analysis. Under data analysis, you can see data.zip. You click on it. And then you need to download the zip file. And it's pretty simple. You download the zip file first, and then you see a bunch of files, data files. You can see CSV. So CSV and TXT. TXT is for the original data, and other CSV files are for data files of different labs, because the RL consists of multiple labs. And you can download CSV with Excel, and for TXT, you can download it with test document. And does the data, all the data needed for evaluation production of the research appear to be available? I check it, and the former student check it. Yes, all the data appear to be available, because there are many labs in this study. And we just check if all the labs, if the data of all the labs are available. And in this case, yes. Now this is a key question here. You need to be careful with this. Are the data understandable? Now, back to the OSF link. Look for codebook. Here, you may just search codebook here, and you can find it here. Codebook analysis. So what is a codebook? So basically, there are tons of variable names. V1, you may not understand what V1 is, V1 is, without looking at the scope. And through this codebook, you can see the description for each variable, which is actually pretty clear. So this codebook makes the data understandable. There's some scales here. And the next question, are the analysis scripts or code available for download and analysis? Now you be careful and check carefully. You may search the word script up here, scripts.zip. And then you download the file. It may take a while. And you can see some R files here. You download the zip first and download R files. So make sure you have R Studio first before you can actually download the R files. So the final question is on data use license. To check this, this may be available on the journal article link here. Under Show All Authors, you can see the CC-BY, which means that it's a general permissive license that requires attribution. It's a Creative Commons, but a Creative Commons that requires attribution to the original authors. Yeah, so yes, it's a CC-BY license. In this case, students didn't realize this. They didn't find the license, so be careful when you check if there's license. Be careful with this symbol, CC-BY. So as you can see, it's relatively simple. It doesn't take a lot of time. But you have to be really careful for checking, particularly the files, whether the files are understandable, whether there's license. Students' answers is here. They answer all the questions, all the items correctly, except for the last answer. There's a CC-BY license, which means you can adapt, but you need to attribute. And the next part, reproducibility check based on Rick et al. This means that you need to check the results and we run an analysis with the data, code, syntax, analysis files available. So you need to check for 4 types of error. First, insufficient information error. Sometimes the data, the method, information may be too ambiguous or may seem to be absent. Like if the data or the code is too ambiguous, it's very difficult to reanalyze it. And then there may be minor numerical error and major numerical error, which is based on the percentage error here. So obtained minus reported over reported times 100. So if it's below 10%, it's a minor numerical error. But it's 10% or above, it's a major numerical error. And the decision error, which means is there an error in statistics used, reported, or interpretation of results? So here this is important. If there's any one of these three, insufficient information error, major numerical error, and decision error, any one of these three, this is a failure of reproducibility. But if you see that's only minor numerical error, but not any of this above 3, this is still a successful reproducibility check. Here is an example. The students check for if there is insufficient information error, and the analysis instruction was not here, was kind of ambiguous. They also found major numerical errors, which means they try to reproduce the data set. There are 70 naps. Why 70? Because there's 70 naps, and they couldn't reproduce the results based on the instructions. They found slightly different data. You can see this page to reproduce PSYC and the reported PSYC are different for different labs, all these labs actually. So this is an important point. state the effect size unit here. So I'm not sure what the effect size unit is. I think this is scope entity. Please do state the effect size units when you report this. And Decisions did a great job in checking if they can reproduce the original results based on the data core available. There may be some problems with the instructions. And then the next step, the pre-registration assessment. So first, check if the hypothesis are available and clearly stated. If it's available, copy and paste the hypothesis with direction, number of tails for the test of the hypothesis, and location, the page number of the hypothesis. And then this is followed by inclusion and exclusion criteria. Please check if it's available. If it's available, copy and paste the criteria and assess the specificity and whether it's interpretable. Sometimes the inclusion and exclusion criteria may not be specific, maybe a bit too vague. So please assess this. See whether you fully understand what the authors mean. Third, please check for the power analysis. Do they specify how they want to have power analysis? Check if the analysis can be reproduced. And check if it's accurate. If there are problems, please describe the issues and difficulties. We will talk more about power analysis in the coming session, in the coming tutorial session. And then you check if the pre-registration states the number of target, number of participants, or range of participants, and the time, and the method of data collection. Also check what is the plan if the preset sample, target sample cannot be met. So for design, indicate if it's experimental or non-experimental. The other have to specify issues on randomization and description of blinding of experimenters. This may not be applied for our replication project, as we recruited participants from AmTurk, so there's no such issue related to the blinding of the experimenters. AmTurk is online crowdsourcing sites for online data collection. And the next part, data analysis. You basically check how did the original authors, how did the RR deal with the incomplete or missing information, missing data. How do they define missing data? How do they define incomplete data? You check for the procedure and what are the methods for checking for randomness of this missing the incomplete data. And then check for statistical assumption and violations, like this may include the fin test, whether violation normality, etc. You check for outlier detection and handling. How do they handle outliers? And then you check for reproducibility and calculation of measurement variable. Two types, non-composite, one measurement, and composite, which means several measurements or items that are combined into one scale, or measurement using a sum or linear combination. And then you check for presence or absence of a model testing the hypothesis. This may be a symbol of encoded and over. And then you also check for the specification and reproducibility of software program. Whether it provides a version number, because different version, there may be different functions. And then you check for inference criteria For example, alpha level correction for multiple tests. And the next part is on the checklist of comparisons. So we'll compare the design between the original article and the RR, as well as the findings between the original article and RR. Whether there's deviation between pre-registration and final reports, as well as data analysis verification. We run analysis. We will come about this in the later tutorials. First, Brent et al. You compare the design in terms of several aspects. First, introduction. Followed by instructions. What instructions are provided for the participants? What sample? There may be differences. Some of the original articles use college student samples, and our replication mostly use amateur or prolific testing setting location, whether it's in lab or online, stimulus, materials that were shown to the participants, sample size. Very often the RR has a larger sample size than our original one. Following session, which means asking participants whether they feel that they're serious to complete the survey, their language ability, whether they had feeling something like this before, whether they can guess the hypothesis, and remuneration, which means payment compensation. So there are 4 columns here: original article, RR, the reasons for the difference if applicable, and the classification. There are 3 kinds of classification. First, accept, which means no difference. Close, which means there's a slight difference in design, and different. So here, this is an example from last year. So what is missing there is there's no reason for the difference. I understand sometimes the RR, the registered replication report, do not provide a justification of difference. But if they provide state the reason for the difference, justification for the difference. I think for most of this, they are either close or different. Sorry, they are either very close or exact. There may be a difference in participants' population and payment, but apart from this, the difference is kind of small. And for our projects, we may also use Labat et al. 2018 to classify the replication. So as you can see, there are different types of replication, from direct replication to conceptual replication. So our replications fall into the category of direct replication. This criteria is based on different design space stats, as you can see here. Apart from the same, there may be slight changes. It may not be exactly the same. Like, for example, the stimuli, there may be slight difference in stimuli, but like if it's still similar, and other things are the same, as 2 or 3 are similar, and with the procedure details and physical setting being different, it's still a very close replication. In reality, there may be slight difference, but overall, it's still a very close replication. So most of our replications are very close. And we compare the results in terms of the original article and the replication with Labat in 2019, which we will discuss further in the later slides. focus is on whether the replication effect size is significantly or not significantly different from the original effect size. Please note that there may be multiple effect sizes, like a study may consist of multiple hypotheses, multiple scenarios, multiple dependent variables. A successful replication means that the replication found effect in the same direction as the original. Practical failure in replication may be due to differences and challenges in methodology or manipulation. And informative failure to replicate means that it's likely the original finding is a false positive. But again, we cannot 100% confirm or prove. We cannot prove. It's just informative. Inclusion means that there may be mixed findings, different scenarios, different dependent variables, different hypotheses. Like we may find support for some hypotheses, but we may not find support for some of them. So now we talk about p-value and effect size. So p-value is the probability of the observed data given the assumption that the null hypothesis is true. So it's kind of black and white. It assumes the null hypothesis. There's no difference between groups, for example. Given the limitations of p-values, they do not tell us how strong the effect is, and it depends on statistical power. We need to report the effect size as well, which is the magnitude of the effect. This may be the size of the difference between groups, in which you use coherence D or strength of relationship, like correlation. So we must report effect size. The APA 5th and 6th edition mentioned that it's almost always necessary to report effect size. So next, what are CIs? So for most statistics, including effect size, which is just mentioned, we need to report CIs as well. Confidence intervals. CIs are intervals we calculate for our statistics with a certain procedure, so that in the long run, 95% of the CIs obtained will contain the true effect size or the statistics that we want to know. This may sound scary, but let's talk us through with an example. Let's say you conduct an experiment to examine the effectiveness of a medication. You give the experimental group the medicine, and you want to test the difference between the experimental group and the placebo group. You repeat the experiment many times, assuming you have reached and have time. Surely, because our universe is random, and because of the laws, you may get varying effect sizes. With each of the effect sizes, you calculated a CI with a certain procedure, let's say 95%. Now you have many CIs. So roughly 95% of these CIs contain the true effect size. We will never know exactly what the effect size is. So the key point is the width of the CIs is an indicator of the precision of your estimation, assuming other factors are unchanged. Level CIs means that the effect size estimation is more precise, and the wider CIs means that the effect size estimation is less precise. Now, this is an example of simulations. You may click on the link. Imagine you want to estimate the mean IQ of a population. Let's say the mean IQ is 100, with a standard deviation of 15. You just enter this 115 intervals 100, 100 samples. confidence interval level 95, calculate it. Then you will see in this plot, some of this do not consist of the original. Sorry, some of this do not consist of the true effect size. Around 95% contain the mean 100, which is the true mean IQ, which is 100. 95% of the CIs consists of 100. So this is due to the sampling variability. Each time you get a different sample, so not all the CIs will contain the true value. And then we'll talk about how do we interpret the results, the outcome of the replication, which is related to effect size and CIs we just mentioned. So there are two criterions, A and B. So for the first criterion, this is assuming the signal is detected in the original study, meaning the confidence intervals do not overlap low, do not include 0. There are 7 cases. Signal consistent means the replication CIs include the original CI. As you can see, the replication CIs touch the original effect size. Let me repeat this. Signal consistent means that the replication CIs include the original effect size. And signal inconsistent larger means that the replication CIs do not include the original effect size. As you can see, it's also larger. The CIs are larger than the original effect size. And further, signal inconsistent smaller means that the replication CIs do not include the original effect size. As you can see, it's smaller. And signal inconsistent opposite means that similar to the replication 2 and 3, for replication 4, signal inconsistent opposite means that the effect is significant in the opposite directions, meaning that the replication CIs do not include 0 and do not include the original effect size, and it's in the exact opposite direction. This is in the negative direction, negative side, and the original effect size is positive. This is followed by low signal consistent, which means that there is no signal in the replication. However, the CIs still include the original effect size. And this is followed by low signal inconsistent. This means that the replication CIs include 0, and the replication CIs do not include the original effect size. And finally, low signal inconsistent means that the replication failed to reach significance, and the replication CIs do not include the original effect size. And in this case, the replication CIs is actually wider. Here, this line is actually wider than the original CIs. And this second part, the criteria B, which is applicable if the original CIs do not include low, meaning there's no signal in the original study. So that 5. Low signal consistent means that the replication failed to detect the difference, and the CIs include the original. Less precise means the replication CIs is wider than the original CIs, as I just mentioned. Signal consistent, that means that the replication detected the difference, and the replication CIs include the original. signal inconsistent positive effect means that the replication CIs are include low, and the replication CIs do not include the original effect size. So you can see it's larger, it's positive effect. Finally, signal inconsistent negative effect means that the replication CIs do not include the original effect size. With an significant effect in the opposite direction in the replication. So here, this is negative, and this is the original is positive. So this is an example from last year. They used the Levin et al. 2019 criteria correctly. As you can see, the replication failed to find support for the original hypothesis. On the effect size of the replication C111 with the CIs overlapping with the low, and the original effect was significant. So this is classified as low signal inconsistent. This means that the results are inconsistent with the original. This is correct. Good job there. However, again, be careful with this. The replication found no effect. Please refrain from using the phrase no effect. An effect of 0.11 is still an effect. Also, the student didn't mention the effect size unit, so please do so in your projects. Another part of the study, the replication found signal inconsistent and in opposite direction. Correct here. The effect size of the original is this, negative 0.35, but the effect size of the replication is 0.24, so exactly opposite direction. So good job here. And now we'll use several examples. We'll do several exercise. So example A, the original coherence D is 0.7, 0.45 CI, lower CI 0.95 with P values falling below 0.001. And the replication D is 1.05. The lower CI is 0.90 and the upper CI is 1.20 with a P falling below 0.001. What should be the interpretation? So please type your answer on chat. So the correct answer is signal consistent larger. At the replication CIs do not overlap with low, and the replication CIs are larger than the original effect size. So here you can see the replication CIs larger than the original effect size. Another example, the original coherence D is 0.5, lower CI is 0.2, upper CI 0.8. P values falling below 0.001. And the replication D is 0.55. The lower CI is 0.4. The upper CI is 0.7. P values falling below 0.001. What should be the interpretation? So please type your answers in chat. So the answer is pretty simple, signal consistent. The replication CIs, which is 0.4 to 0.17, include the original effect, which is 0.5. And example C, the original D is 0.13, lower CI minus 0.05, upper CI is 0.31, p-value 0.321. The replication D is 0.35, lower CI 0.24, upper CI 0.46. P is below 0.05. What should be the interpretation? So here we need to be careful, and we need to use criteria B. As the original CIs include 0, the interpretation should be signal because there's a signal in the replication of the CIs not including 0. So the p-value is falling below 0.05, but inconsistent with the original. And a positive effect. So the replication CIs do not include the original effect size. So there are a few common mistakes that you need to be careful of. So if the effect of the replication is larger or smaller with a signal, the interpretation should be inconsistent. However, even inconsistent, if that clear signal and is in the same direction, it's still a successful replication. Also, if the original CIs include 0, please use criteria B, but not criteria A. This is a common mistake that I actually made before too. So if the original CIs, go back to this, if the original CIs include 0, we should use B instead of A. And then followed by this, the next step is that we need to report the deviation between the pre-registration of the RR and the final report. Please note it's fine to deviate from the pre-registration in the final report. However, there should be transparent reporting of deviations with justification, with transparent and clear justifications. We may document the deviations with pre-registration, planning, and deviation documentation. You may click on the link later. This is an example adapted for our assessment. So there are some components here. First, you should report the location of the pre-registered plan and the rationale. Pre-registered decision state whether there were deviations, whether it's minor or major. So what does it mean by minor and major? Minor means that the changes probably did not affect results or interpretation. Major means that the changes slightly affect the results or interpretation. So if there was deviation, please describe the deviations and the rationale of deviation. How might the results be different if there were deviation or if there were not deviation? Time or dates of the decision. This is the components. So locations should include a page number as specific as possible. Ideally the session, paragraph, or line number. So please provide hyperlinks to make browsing easy. As mentioned, major means the change slightly affect the results, and minor means that the changes probably did not affect the results or interpretations. So now you will see an example by a group of students last year. I think they did a pretty good job with this. So first, they provide a link, the file link. This is important. Operation and the page number. A thing that they can get better is they may mention the session as well. That would be more specific. But overall, they did a great job with this. So again, most of these deviations are minor, which means it did not affect the results or interpretation substantially. So now we can see the slides. So there are a bunch of other examples from the previous year. There are 11 examples of this. So please go with this, you have time. And then what projects you're going to assess? For the advanced social psychology, this is the list. This includes the articles that are already published, some related to action and inaction, morality of direct harm versus indirect harm, meaning ownership and better than average effect. So there are two links here. For published one or under review one, the preprints, you can click on this. For before review links, you can click on this. And this here project list for PSYC3052, some of these are under review by a journal, by several journals. And some of these are related to judgment and decision making, some of these are social psychology or moral psychology. And for PSYC3071, again, two of these have been published. By two pretty great journals, SPPS and Cognition and Emotion. Some of these are under review. These are mostly related to heuristics and biases, judgment and decision making. So, what are the expectations for our assessment? Regarding our expectation, our assessment should be 30 pages or less. 30 pages, like 30, 1.5 space, 11 fonts in Times New Roman. So as mentioned, we prefer a summary or comparison tables and figures over long tests. Tests are still necessary, but please include some tables and figures to make the reader easier to understand. Also try to be concise, short, and clear, but also comprehensive, which means you cover different aspects of the original article, pre-registration of the RR, and the RR final report. And then there's no limit on how many pages you use for appendices, abstracts, references, or other additional information. And this is important too. Regarding the submission of your, please do everything with Google Doc from the very start to finish. Please create a link that allows editing for the instructor freely. See the email address here. So you create an editing, add a link to the document, export it to Microsoft Word, and then submit it to Moodle. We ensure public viewing with commenting permissions, which means that other people can comment, because our work will be shared with the world. And please test if you can access the document in incognito mode, which means that if you're not logged in, can you access the file? Please test it. So the peer reviews, the major aim is to help each other improve. Ideally, to provide suggested suggestions if possible. We'll have the our period templates available later. We will post on the Slack later. Please try to be comprehensive, which means we cover different aspects of the original article, the quality indication, the coding, etc. To be concise, to the point, clear, but not too brief, not too short. Constructive, specific advice on what can be done to be improved, with examples ideally. And supportive, positive support. We all try to make others better. We try to make others improve. Those negative, cynical, or snarky comments, no choice. Also try to appreciate and learn from each other. Try to appreciate and learn from the positive aspects of others' projects. So Q&A, question and answers. So feel free to ask questions during this tutorial or later on Slack. We may not actually know all the answers to your questions, as sometimes we may need to check it ourselves. But we also try to learn, figure it out together through our discussions. It's not a simple question and answer. Sometimes it's more like a discussion. We try to provide answers, but sometimes things are not very clear. Sometimes there are controversies in what criteria we use to assess. The answers are not black and white. So we try to discuss, we try to learn from each other. So we hope that you will learn from our assessment that can be transferable for your replication projects, for your future projects, for your thesis, etc. And these are the references. So now you feel free to ask questions. Thank you.